Hello, Namya.
Hello.
Hello. So your name is Namya, am I right?
Yes.
Okay. So let me first introduce myself. My name is Arna Prasad and I am from India. So can I know first, where are you from, Namya?
I live in England.
England. Okay, fine. So let us start our class. Okay. So you choose the topic momentum to start with, right?
Okay. Yeah, I think.
Yeah, so before that, because generally the momentum is studied after force and inertia and all that. So let us have a quick revision, just a small revision. And actually, already I have shown you the definition in short form. Can you tell me what is force in simple form? You are in ninth grade, right? Yes or
Yes.
hmm. In simple words, what can be simple or proper language? What is force?
Force act upon an object to change its direction or speed or whatnot.
Yeah, direction of
Direction of movement.
yeah, direction of anything. This is half definition. As you can see here, let me use my annotations. So as you can see here, the examples are given: push, pull, kick, catch, lift. Anything, any object on which if you apply a push or pull, that is counted as force. And yes, of course, changing the direction of the body also comes under this category, but not only changing the direction, even when some object is at rest and you are trying to move it, that is also possible by applying force only. For example, when the ball is at rest, you kick it, or the football players when they kick the ball with their leg, the football or the soccer ball, so it starts moving, so that is also force, right?
Yeah.
Now, inertia, can you tell me what is inertia? Again, just one definition if you remember.
I don't think I've studied inertia.
Can you say louder? Wait, I am increasing my I have increased the volume. Can you repeat again now? What did you say?
I haven't studied inertia.
Ah, okay. Then I am going to give a small introduction to that as well because I have started this topic. So as you can see here, okay, which changes or tends to, no, here proper definition is not given. I'm just showing you and then I will explain from there. Because let me tell you, I am the teacher who prefer just showing you the slides and explaining everything from there. So this
Okay.
is the definition. Inertia. Can you read it out first?
A property of matter which resists change to the state of motion and rest.
Right. So let me tell you, Namya, whenever we apply the force to any body, then all the bodies in this universe tends to restrict the force which is applied on it. For example, here multiple examples are shown on the right hand side. You can see. Okay, I am taking the best simple example which you would have noticed, and very famous example as well in eighth and ninth grade books to understand inertia, force, and momentum and all that. So when like person is sitting in the bus and the bus is at rest, when suddenly the bus starts, we feel a jerk and we step forward or backward. Think.
Forward. I
Uh,
mean, brake, you would go backwards, and if you
Right,
accelerate, you'll go
right,
forward.
backward, because we are like our legs are in touch of the bus, our legs are touching the bus, the floor of it, but our upper part of the body is free. So it is not ready together to face that sudden change. That's why we get a jerk backward, but slowly we get a what you say yeah, we get adjusted, and then the inertia is like the inertia left the role, leave the role to play. Similarly, opposite is the case when the bus stops. In which direction we feel the pressure or force when it suddenly
Forward.
stops? Forward. So same is the reason that when the bus is suddenly stopping, especially suddenly, like how quickly the bus or the vehicle in which a person is sitting, how quickly it is stopping, it depends upon the inertia depends upon the speed. That's why. So that time we just fall forward because our body, the upper part of the body, again wants to remain in motion, but suddenly it is allowed or it is said to just stop because the bus is stopping. You will also have to stop. And we slowly take time by moving forward. Is it clear up till here?
Yeah.
Any questions? Because I'm now going to take momentum, which was your request. Any questions up till now? No.
No.
Okay. Now taking the momentum now, do you have any idea about momentum, Namya? Then you can tell me. Otherwise, I will explain accordingly. Like, or is it a complete new topic for you?
Completely new. We've just started my year. So.
Okay. Then I am going to explain it. Let us go one by one. Here the definition and the formula is given, and after this we will have multiple examples. Let us see how much we can cover today. So momentum, wait. Yeah, momentum is the quantity of motion in a body and it depends on its velocity. Means, what does it want to say? When we apply the force on a body, then obviously it will be in motion, either be in motion, like it cannot be always in motion. We can even apply the force to stop it. But when we are talking about motion, not stopping, then momentum comes into play. Means how much is the body is in motion, whether it is going in slow speed or fast speed. Also, this is the first quantity on which it depends, and on the mass, or in simple rough language or casual language, you can say weight as well. What is the weight? Let me tell you, Namya, that in casual language, we generally say, yeah, mass and weight is the same thing. But when we talk in physics properly, mass and weight is not same. They both vary. But to understand, um, like when the learners are just learning, the students are just starting learning in 8th and 9th grade, these things, the teacher simply explains that yes, you can, as of now, you can take weight as weight and mass approx same, but actually they vary.
Yeah, we learned weight and mass was different.
Yeah, that is the thing. But that is separate topic. I'm not covering it yet right now. Now, so it depends on the mass. This is the first thing, and this is the formula actually, what we are talking about. Mass and the velocity. Now, velocity, have you learned what is velocity?
I might have, but I don't remember.
Okay. Velocity is the rate at which the object changes its position when it is moving. Like, for example, I will start walking from here, from left. Let us say my left is this side. So, from left to right, what is the direction specifically? Direction also matters when we are talking about the velocity. I'm saying, and same goes with momentum. You will learn these things in scalar and vector quantities. Okay, that is later on. Right now, this is the definition as I told you. So momentum is quantity of motion in a body which is calculated by mass into velocity. So these two things matter. How much is the weight and with what speed it is moving. Momentum of a body is defined as the product of its mass and velocity. Now let us understand this thing. Let me check what next they are taking. Then I will take the examples. Momentum is directly proportional to mass. Do you know what is the meaning of directly proportional or inversely proportional when we use these terms?
Directly means like it's the same proportion.
Yeah, same, exactly. and inversely means opposite. For example, in simple language, I am saying you when a body has great mass, do we need to apply, for example, an elephant? If Namya is asked to move an elephant by applying pressure to it, so obviously it will be harder for you or easier for you when the mass is great or bigger. The
Hard.
pressure, what?
Hard.
Your voice is not clear. What are you saying? More
I'm saying
or less, the pressure which you will need to apply to move that body like an elephant will be greater or less?
greater.
Greater. So obviously, in the more is the mass, the more pressure we need to apply. The lesser is the mass. For example, a small ball. The same now same activity. If I will say Namya to apply to a ball, so obviously Namya will say I can just do it with my hand, even with one small finger. I can just hit it and it will move. So here it is directly proportional. Okay, these are like in this way directly proportional and inversely proportional are taken into case. Inversely proportional means just opposite. Like for example, one matter or one thing is increasing, then the other will decrease. Like this it goes. For example, right now from here only we can clearly find like P is equal to mv, or we can say m is equal to P upon V. When V will come here, it is multiplied. Here it will be divided. So mass and velocity are opposite. The greater is the mass of the body, the more, like you can say, we need the force to keep it in motion. Like if again same thing I will give example, like if elephant or ball we talk about, or a big vehicle like car, bus, or simple cycle if you will take about, the bigger is the mass of the body, the more velocity, the lesser velocity it will have with the same force when you are applying. Say I'm repeating, same force, but same force when applied on heavier body, it will move with lesser distance. But when applied on the smaller body or a lighter body, can move it easily. Did you understand? Up till now, what I explained, we will take many examples to understand all these things.
Okay.
Okay. Now, yeah, so directly proportional, I gave the example. This is directly proportional and this is inversely proportional. Now, if a cricket ball, now the examples are taken. If a cricket ball and a tennis ball move with same velocity, momentum of cricket ball. Now, they both are approx the same in mass, you can say. And they are also, they are taking example, they are moving with the same velocity. Momentum of cricket ball is more because its mass is greater. Okay, they are considering the small variation even. Now, I just want to know, do you like cricket? Do you watch cricket? Yes or no? Yeah, right?
Yeah.
Okay. Your voice is not clear when you are speaking slow now. I can hardly hear you, so you will have to speak little louder or you can come closer to your laptop. So yes, because cricket ball is harder little bit in comparison to the tennis ball, and of course mass is also greater. So therefore the momentum which is needed to, momentum means to keep the body in motion. I am repeating, is the quantity of motion in a body, how much the body is moving. Because the mass of cricket ball is more, we will need momentum more for cricket ball. Is more because its mass is larger than that of the tennis ball because it is lighter. Let us understand another example. Now here was the example of mass which they gave. Now we will take velocity. According to this formula, momentum, this P is directly proportional to both of them, mass and velocity. So they are explaining accordingly. Now, if two cricket balls, obviously they both can be considered of same mass, but they are moving with different velocities. For example, one player threw it with greater force, but the another cricket player threw it with slower ball, like slower ball he did. Then the momentum of the ball with the greater velocity will be more because V is increasing in this case. So obviously, ultimately, momentum will also increase. Clear? To keep the body in motion or to keep the cricket ball in motion. Any questions up till here?
No.
No. Then wait, light is gone at my place. I'm bringing light. Just wait for a few seconds. Yes, Namya. So now an interesting question for you is, if a body is completely not moving, is not in motion, then what will be the momentum of the body for such cases? Like the body is at rest. For example, I am also at rest right now. I'm not walking or moving. You are also at rest. So what will be the momentum? Guess. Because
Nothing.
what?
Nothing.
Right. Absolutely correct. It will be zero. Correct. So if a body is at rest, its velocity will be zero and hence the momentum will be zero. So like for example, let me show it in terms of calculation. Like P is equal to, let us say that the weight of Namya is around 35 kgs. And but velocity is zero because this is multiplied by zero. That's why in terms of maths, I'm just showing this. Momentum is coming zero. Okay. Now, Newton's second law of motion, this is not required because you asked momentum. I am skipping this. Wait. Law of conservation of momentum. This is important topic. Let us understand this. Acha, wait. I have few more examples. I want to ask you. You want to take more examples to understand it, or you want to go with law of conservation? Like you are clear with the examples. What is exactly momentum?
I want to do law of conservation.
More examples, na? Right. More examples. I will also prefer that. So here are more examples. Let us see if I can get if a cricket ball and a tennis ball. This is totally same. I'm just seeing if I can find. Yeah, I found it. Importance of momentum. I have just chosen 2 PPTs for you to take the demo today. So importance of momentum for considering the effect of force on motion. Example, suppose a light vehicle like a car and a heavy vehicle like a truck are parked on the horizontal road. Same example they are giving in like just changing small like little bit in the situation. A greater force is required to push the truck than the car to bring them to the same speed at same time. Do you agree? A greater force is required for the truck in comparison to car.
Yeah.
Similarly, a greater opposing force is required to stop the truck. For example, if both of them are moving and you have to apply brake, so obviously a greater force through brake is needed to stop for the truck than the car. Clear? The first one?
Yeah.
Now, this is interesting question, interesting example. A bullet fired by a gun can easily pierce, you would have seen at least in movies, I think we all have seen, like how whenever the bullet is fired, like it can easily pierce the human tissue or the person get hurt, even die. So before it stops, resulting in casualty or even emergency situations, but same bullet when moves with moderate or lesser speed. Okay, the condition is the speed is decreased. Obviously, the damage will be less. It will not be able to go deep inside the body. Why? Because more is the mass, thus for a given mass, sorry, not mass, here mass of the bullet is same. Greater is the speed of the bullet, greater is the opposing force needed to stop the body in a certain time. So obviously, greater is the momentum. Ultimately, momentum is greater. Momentum depends upon the speed and the mass. Is it clear?
Yeah.
No questions? You haven't asked any questions. Very few questions like student ask I have seen. Mostly they are cleared. Okay. The force not depends on the chain but also on how fast the chain that is repeated. Leave it. Now something important. Now they are teaching vector quantity in terms of vector quantity as well. I want to know, have you learned scalar and vector quantities?
No.
No. Okay, then I am considering this part. Okay. For that, I will need to give you examples. See, different quantities in physics are depending upon whether it just depends on, just a minute, direction, or let me just check. I'm just forgetting. Direction and just wait. Yeah, the magnitude and the direction. Do you know what is magnitude? Like if I talk about what is the, because many a times the student don't understand what is this term magnitude.
It means the greatness, like the size.
No, magnitude means the value. Okay, whenever the terms because when you talk, when you will go through the definition of scalar and vector quantities, na Namya, this term is common. What is the definition? Like depending upon the magnitude and direction, the physical quantities or any quantity like force, momentum, mass, velocity, speed, distance, etc., whatever you learn, it can be categorized or divided into two types, scalar and vector quantities. So two things they depend upon, magnitude and direction. Direction is understood. But what is magnitude? Remember always, it is the value, the numerical value which that quantity has. Example, now momentum, I already told you that momentum and force. Now you will think an answer. Momentum, do you think it just depends on magnitude? Magnitude, all the quantities, all the physical quantities depend on magnitude. That is fixed. Only direction varies. When the if I'm asking you for momentum, apart from magnitude, do you think it depends on direction of the body? Yes or no?
What depends on?
What?
What depends on magnitude and direction?
Yes. That's why it is a vector quantity. So they are writing the following example shows that momentum is vector. We will understand this later on, but first, because I have taken this topic, vector and scalar quantity, so that's why I am giving you example of scalar quantity as well. Quantities like simple things, speed, mass, not velocity. Uh, Neither acceleration. Acceleration is also vector. So I'm just giving you two quantities like speed and mass. These are scalar quantities. Sorry, scalar. Okay, this is the spelling. And yeah, it depends only on the value, the numerical value of the the speed of a body or the mass of the body, not its direction. Obviously, I'm giving you in simple words a definition like mass, very simple. Whether you will sit here, whether you are moving, whether you are going upstairs, you are going down anywhere, your mass will remain same. It will not be affected because of that. So direction is not counted. That's why these things, these simple quantities are scalar. But when we go in deeper, the detail like momentum you are learning right now, all those are counted in vector quantities. They depends on direction. Now let us understand the situation. Can you guess what is happening? You can see in the picture. Think and answer.
He's moving a stone around in the air.
Right. So he is turning around in a circular motion. So obviously direction is being counted here, right? Let us see what have been written. The above example do not indicate that momentum is a vector. Earlier, what we just went through, they are talking about that. The following example will better clear it. So suppose a stone is whirled, stone or ball, anything with uniform speed. Now, what is this uniform term?
Like in the same speed.
Right. Same, equal speed. And opposite of it, the term which is used is non-uniform speed, means unequal speed. So uniform speed means in this circular motion, every time the speed is taken or imagined to be equal, approx all the time. In a horizontal circle, this is the horizontal circle in horizontal direction, not the vertical one. That's why they have just added horizontal here. By means of this string, where is the string? This is our string, the purple one. The magnitude of momentum is constant, but its direction keeps changing continuously. So obviously we can see here, Namya, that this boy is regularly to keep the ball in motion, because momentum will be counted only when it will be in motion. When it will be at rest, it will be zero. So to have the motion, it is needed to be continued to move. Sorry, to have the momentum, it is needed to be continued in motion, and that is applied by this boy, but in a particular direction. That is the horizontal circle. This is the direction, you can say, if it is continuously moving in circle. A force is needed to change this momentum vector. This is the force which is applied by him. This force is provided by the hand through the string, and it is also felt by the hand. Clear? I have explained like a small kid. Yes or no?
Yeah.
Now ask questions still, if anything running in your mind.
No.
No. Then let me see, what should I take next? We have taken plenty of examples, so I am thinking of taking law of conservation of momentum. So what does law of conservation of momentum states? Let us see, we will understand one by one. The law of conservation of momentum states that if no external force is acting on a system, the total linear momentum will remain the constant. Like like we will consider a situation in which two bodies are collided to understand this law of conservation of momentum. So before the collision, how much the speed with which the bodies were moving, like imagine two balls who are trying to collide. Before the collision, before they are smashing, whatever the speed they had, that is overall equal to after the collision. This is the definition. States that if no external force is acting, obviously if any external force, for example, a very huge wind is blowing, then it will change the direction and the speed as well of the body. So that is separate case. That's why this condition they have applied, that external force should not be there during the collision. Then linear momentum will remain the constant, or in simple words, momentum will remain constant. It will not change. Before collision, after collision, they will be same. Now, this definition, which I explained you orally, you are going to learn in terms of this formula. Okay, by considering the example. And yeah, this will, this is another few more, two examples are given for momentum as well. Acha, one more thing, Namya. After 10 minutes, the meeting will end. We can rejoin the class for the rest time. Okay. Like this is my common link. Let me tell you, I have not taken a like premium plan of Zoom. So that's why after 40 or 45 minutes, it ends, and then the student and the teacher, that is me, rejoin, and then we can have the rest of the class. Okay. Okay, Namya.
Yes.
Okay, so now see what is happening here. Suppose a big and a small car move in the same direction with different but with different velocities. Now I'm increasing the size. Let the mass of the bigger car be m1 and initial velocity of it is represented by u1. So these things are important. This is for our concern. Wait, I'm using this. Yeah. So this is what we have to remember for applying the formula and the derivation part. So suppose that during the collision, the bigger car exerts a force F1 on the smaller car, and in turn, the smaller car exerts a force F2 on the bigger one. Let us say they are moving in same direction, but due to some reason they collided. So when the force F1, F1 means 1 term is for the bigger one and 2 is for the smaller one. So I hope it is readable for you, right? This thing? Okay.
Yeah.
So when the force F1 acts on the smaller car, now this is the general formula. I have not taken force for you. I hope if you have learned already. The formula for force applied on a body is equal to m into a. Mass into acceleration is equal to force. Have you learned?
Yeah.
So that is applied here. So when force F1 acts on the smaller car, its velocity changes from u2 to v2. F1 acts on the smaller car. Yeah. So u2 to v2. This is again. Now this force F1 is applied by the bigger car, and these are the values for the smaller car. So therefore, F1 is equal to m2 into a2. Is it clear? Force is applied by the bigger car. Because it is applied on the smaller one, it will be equal to its value, mass and acceleration for the smaller car. Now,
V?
what's V?
Yeah.
V is velocity. That is, I am coming to that next one. Now, what is the formula of acceleration? Acceleration is the change in the velocity of a body. Like in simple words, when we define what is acceleration, this formula is hidden in that definition. That with what rate the speed, in simple words, it is actually speed, but better term is velocity. With what speed with what, like in what rate the speed of the body is changing or the velocity is changing, that is acceleration. So now a2 is for smaller car. So obviously its velocity, which is shown here, sorry, its value will be again for the smaller car. So this is final velocity minus the initial velocity. Like here it was given, its velocity changes from u2 to v2. So final velocity minus initial velocity upon time t. Let us say for some time t, like what time, during what time, like total what time was taken to for all this these things to happen. So this is the formula, remember. Okay, it is also written as A is equal to dv upon dt. So don't get confused. D represents the change. Okay. Now, when the force F2 acts on the bigger car, I'm moving to the next part. When the force F2 acts on the bigger car, its velocity changes from u1 to v1. So F2 is applied by the small car, but on the bigger car. So these are the bigger car values applied by the small car. Acceleration, similarly, acceleration is acting out like I explained for the bigger car. This is for small. Sorry, this is smaller car. This is for bigger car. Up till here, see carefully. Is everything clear?
Yes.
Now, I have not taken Newton's laws. Now Newton's laws is going to be applied after this. So again, I am considering only Newton's third law. Do you remember who is Newton?
Yeah.
Definitely. What do you remember right now about Newton? You can tell me.
We discovered gravity.
Right, absolutely correct. Not only gravity, let me tell you, force also, momentum as well, many things in physics. That's why the name also, like the three laws, which is going to be learned in these correlated topics, is named as Newton's first law, second law, third law. Now, according to Newton's third law, Namya, um, the body, for every action in this universe, let me tell you, whenever two body collides, in that case, when the one body is reacting or doing some action on the other, there is equal and opposite reaction by that body on the previous one as well. Here, what is happening? Because the bigger car is smashing the smaller one, smaller car also reacts from its side, but because it is smaller, we are not able to see its, like you can say in simple words, the struggle or the push or pull which it is applying, only because the bigger one is leading, so it is visible. And same thing is applied everywhere. When we are pushing the door at our home to open or close it, the door also applies the same push and pull to us as well. And another example, like if any body is falling towards the earth, because of the gravitational pull, earth is attracting it towards itself. Similarly, that body is also attracting the earth towards itself. But that is very small. For example, a ball, again, I will take the example. A small ball is very, like, just a tiny quantity, a tiny object in front of this whole big planet Earth. So that's why we don't see the ball moving towards the earth, sorry, the earth moving towards the ball, but vice versa is visible. This is Newton's third law, which they are applying here. Wait, I'm erasing this all so that it will look little simpler. Now, according to Third law, as I told, before the collision or after, like every action and reaction, for every action, like what is the proper term that I'm telling you? For every action acted upon a body, there is an equal and opposite reaction given by that body. So this is what one car is applying the force, that will be equal to the other force which is applied by the second car. Means 1 and 2, they both are same. Two equations are equal. F1 is equal to minus F2. Minus. Can you guess why it is minus?
Because the F1's force.
Because they are in opposite directions. This is vector quantity. So obviously when one is coming from this side, the otherwise is coming in. No, here it is not that case. Here they are moving in the same direction. Here direction is not completely considered. We cannot consider, but definitely they both are equal. So that's why one will be negative, one will be totally opposite. That's why negative. Equal and opposite force, but one positive, one negative. Like this it goes. Now that's it. Nothing is left out. We have to cancel out the terms which are same, and then This is left out. After simplifying, shifting the terms properly, this is the final part showing the law of momentum. Initial momentum of the bigger car.